Hi, and welcome to another Dante tutorial. This time we're going to show you how to simulate a quench hardening process using Ansys and Dante. This video is a continuation of the previous gas carburization tutorial, so make sure you check that out before I get started. Link in the description below. We're going to start by dragging over a transient thermal module and placing it on the project schematic. Then connecting the model from the ring slice we previously made to the model in the new module. I'm going to also rename this module to Oil Quench Thermal Model. Turn on Dante Act under Extensions, and then double-click Model to open Ansys Mechanical. Once Ansys Mechanical is open, go to the Home tab and click Unit. Make sure the units are set to millimeters, degrees, seconds, and Celsius. Confirm that the model looks correct and that it still has a name selection and the inflation layers on the mesh. Click on the Dante model and select Thermal. Next, we're going to define the process steps. Let's go to the initial temperature under the project tree and set the initial temperature value to 20 degrees Celsius. Go to Analysis Settings and set the number of steps to 7 and then the current step to 7. This is important since step times need to be entered from highest to lowest. From here, I'm going to change the step end time, initial time step, minimum time step, and maximum time step according to this chart, while also setting the auto time stepping to on, defined by time, carry over time step to off, time integration to on, and nonlinear formulation to full. Next, let's assign the material by going back to the Dante tab and clicking Material. Click Material in the project tree and then click Geometry. Select the whole part as the geometry and click Apply. For this tutorial, I'm going to assign the S10XX as the material, change total carbon weight fraction to 0.002, and make sure this is set to thermal. From here, we're going to define the control file. Click Model Controls in the Dante tab, and we're going to click Kinetics Mode Table and set the Phase Transformation Kinetics Mode on steps 7 and 6 to -6 to include tempering, and then click Apply. Next, I'm going to add the output frequency by going to the Dante tab and clicking the Output Frequency button. I'll click on the tabular data, and for this tutorial, I'll leave it as default of 2 per step and click Apply. Next, I'm going to create the thermal boundary conditions. Go to the Environment tab and create 5 convections and rename them to Heating, Transfer, Quench, Air Cool, and Temper. For heating, change the scoping method to name selection and select the outer surface that was previously created. Set the ambient temperature to 875 degrees Celsius and set the film condition to tabular, and in the tabular window, deactivate all the steps except the first. Set independent variable to temperature and coefficient type to surface temperature. Lastly, I'll enter this data into the table. For transfer, change scoping method to name selection, choosing outer surface, and change the ambient temperature to 180 degrees Celsius. Change the film coefficient to 0001, and in the tabular data, right-click to keep active step 6. Next for Quench, I'll select the outer surface as the name selection again and set the ambient temperature to 65 degrees Celsius. Set the film coefficient to tabular and right-click to activate only step 4. Set independent variable temperature and coefficient type to surface temperature. Enter this data into the table. For air cool, again set the outer surface as the name selection, set the ambient temperature to 20 degrees Celsius, and set the film coefficient to 0.0001. On the table, right-click and deactivate every step except Step 5 and Step 7. Lastly, the temper. Again, set the outer surface as the name selection. This time, set the ambient temperature to 185 degrees Celsius, and the film coefficient will again be 0.0001. Right-click and deactivate all the steps but Step 6. Next, I'm going to add the carbon profile from the DANTE tab and set the number of carburization profiles to 1. Then I'll click Carburization File, and then find the CBN file. In this case, I'll go to my working directory, then under Dante_files, I can find the CBN file. Under Carburation/Nitriding Activation Table, I'll select Tabular Data, then set the carburization step under 2 to 1, and then hit Apply. Now we're ready to run the simulation. Click Finalize Model Settings and right-click Solution in the model tree and click Solve. This simulation may take some time to run depending on several factors such as number of CPU cores or the size of the model. For a part of this size, it should only take a few minutes. Once the solve is done, you can go back to the DANTE tab and click Total Hardness under DANTE Results. Right-click that and select Evaluate All Results. At this point, you should be able to see the results and play the animation to see the evolution of the hardness as it goes through the steps. You can also go to the Home tab and click Section Plane, and by dragging a line across the model, we can see a cross-section. Make sure to save your work before you close out of Ansys Mechanical, and save again when you're in the Ansys Workbench. And that concludes this DANTE tutorial. If you have any questions, feel free to comment down below or send us a message at support@dante-solutions.com. Thank you for watching and happy simulating.